Hello there. Recently, one of my friends decided to part ways with his Creality CR-30, and naturally he yeeted the thing in my direction. As a belt printer, figure I should review it, compare it to the print shift, check out the printing style, but mostly I want to go over what do you do when you get a new to you used 3D printer. How do you check it out? There's plenty of these things floating around, generally you can have them for a song, and usually they're a great deal. But also usually there's a reason folks are getting rid of them. In this case, the gentleman is standardizing on IDEX printers to increase printing capacity, and he's never really enjoyed the print quality out of here, so we'll see how it's done. This printer is familiar to me because while it's been in production, I've been maintaining it for much of that time. I've been printing thousands of small little rocks, and you can see there's a lot of crud on the bed, and even stuck in here. That's annoying. Now, I've got this gentleman up on the bench. Before plugging in, he's unplugged, I'm going to go over any major problems. First, checking the electrical system. Get you guys a little close up. So, how does the printer work? Power input here, power supply, electronics all underneath a nice rack. All the cables coming out. Big thing to look your cables for are any wear points, any pinch points. This is not ideal. There used to be a strain relief in there. That's wandered off. You can see there's some stress. The extruder's moving back and forth. The CR-30 or 3D print mill is a core XY machine. So you have your XY motors here, and your belt driven by a motor down here. Belt motor is buried. And so you have it is a stepper, but it's running through, that's actually, if you can see that, reduction gearbox. Don't know how big it is, but then a belt drive up to here. End stops on the gantry, which is interesting. Probably so that they can have all this in one thicker wire bundle. Remote, or Bowden extruder. It is a dual drive gear extruder, so that's nice. There's also a filament out sensor. So this cable never actually moves, but this one moves around a lot. I consider any repetitive motion cables to be a consumable. They will last a long time with good strain relief, and this is not bad by any means, but they rarely last the entire life of the machine. Looking for, we have one end stop. There should be another. There's nothing at the top. This is actually a aftermarket NAC 3D improved motor kit. I did install this myself, but I'm still going to take a look at it. Anytime you're checking on a printer, debugging, anything like that, you never trust the guy before you. Especially if that guy was you. Here we go. So this is a little... Oh, look at that. This... Focus. This little gate here. That's an optical end stop. These two channels. And if we look down here, there should be a paddle. Yep. That paddle triggers the optical end stop. So there is an opto end stop for the gantry bed leveling. Now, because this is an angled belt printer, the only thing you really need to be concerned about for bed leveling is that the extruder is perpendicular to the bed along its entire length. You have some bed adjustment screws. This one's loose. Apparently just the top is loose. Interesting. Tighten that up. Electronics, I don't see any problems. I'm a little worried about some of these cables being a little loose and a little close to the belt. Especially this end stop cable down here is loose and close to some other belts, but nothing a few zip ties won't fix. Now in your Core XY, there's nothing that keeps this axis perpendicular, the X and Y axes perpendicular, except the belt tension. So if you look here, as I tension the belt, focus. If I increase the tension on this belt, you'll see I'm actually bringing the axis out of perpendicular, out of square with the bed. The way this kit is set up is quite nice. This motor is held in place by screws on the inside, bolted strongly to this side of the frame. But then this screw, you can see through here, is actually the tensioner. So in order to tension one side versus the other, I could loosen here, tension here, and then retighten it so it's nice and solid. And this kit is quite new. Couldn't really achieve an improved print quality. I think it's more just the angled style, but we'll see how it goes. Let's see how we're getting. Another, I'm just sort of looking for loose stuff. The LCD used to stick out the side, I'm guessing. Guessing that was just in the way of operations. But this is your standard character LCD, not character, whatever, the monochrome, black and white, click encoder. There's no reset button, which I always like to see a reset, just makes me feel better. Let's take a look at the underside, see what else we got. We do have the power coming in on this side. Switch still seems reasonable. I'll stick you guys back up somewhere stable. One thing that's not coming through is how heavy this machine is. It is rock solid. Although actually, before we move on with that, you have these screws down here. Those are for tensioning the conveyor belt. Where I'm pushing here where there's no support on it. There's supports here and here. I believe this part is heated and that this part is not heated. Definitely the first place that your belt printer is going to fail is with maintaining adequate bed tension. So we can see the electronics. You can actually see the outline of the power supply right here. It's just the standard big silver metal guy. Electronics on me. I'm going to open up real quick just to look for any burnt bits. It's apparently only ever printed gray PLA. It's just coming out of woodwork everywhere. Fan in here. Make sure to plug that back in. And you can tell it's been running a while, but in a pretty clean environment. There's no hair or fur on there, but a lot of dust. Wow, this is remarkably clean inside. Custom Creality board, USB, or whatever, SD card in there, and the USB port for updated firmware exposed. Looks like an old, it's actually an ARM chip. I was going to expect this to be an old Atmega based board, but it's got an ARM controller. I'll just look that up and look for more firmware, but cable management is really well done. Like, a lot of places you have problems are the power switches being not rated. This is interesting. They cut a hole in the 2040 extrusion here to put the power switch in, which is just... It's not like that's a bad thing to do. It's just... That's a lot of work for... just to meet this profile. Here too. They cut a hole in the... Wow. I see absolutely no problem with this machine. It's remarkably well built. So, yeah, we're going to run into the test print. The belt on this guy is angled at a 45, or the extruder is angled at a 45 degree to the belt, which allows you to do part ejection with a 3-axis machine, which is quite nice. It also allows you to print things larger than the machine itself. So first test print's going to be a little short, small thing, but when I'm getting a new machine, I like to queue up a long test print before I do any updates, any upgrades. That way, I can find any problems before I've invested time into the machine. I plugged it in and turned it off. I must have hit the power switch in that. Little custom, that's cute. So 2.0.6.3. I wouldn't update the firmware immediately. I'm going to do the test print first. Or first I'm going to test the heaters, the axes, and see how our zero looks. So for motion, If you run the auto home, then I'm going to move the x-axis and just watch how we are close to the bed. And that looks like it's still trimmed. Be a little higher on this side. I'm gonna adjust that. So you unscrew the bottom, which allows you to adjust the height. And yes, I'm just doing it by eye for the first step. I also want to check the Z. You notice in the homing the belt didn't move at all. Solid, stable. I'm in the wrong direction, but you know, it does say minus. So these are all the priming splotches, which I would recommend you have them splooch the other way, but I'm assuming that's what the default is in the slicer. Which was also one of the complaints on this, is that the slicer only runs the Creality, because other machines are just running Prusa slicer. Just the final thing to test are heaters, and I'll do a test print. So we got both the heat bed and the nozzle going. I'm also curious, I think only this portion is heated. There's multiple plates. Disable steppers so that I can move things around manually. Nothing on the motion system is loose at all. This is generally your biggest problem with the Creality type machines. Now, one of these axes has been already replaced by linear rail. Should also check that. There's zero play there. You should never be able to roll one of these wheels without moving the gantry. So that looks quite good. Full tension. This hexagonal nut here is actually an offset cam. So if you need to tension this wheel, you rotate that and it changes, you know, it's an offset hole. So as you rotate it, it will tighten or loosen this. These are in turn held in place by just these lock nuts. So the lock nuts, if they're not providing enough clamping force, they come loose. You really just need to replace them. And they're only a few cent part, but if you're having a CR-10, any sort of Creality, or any sort of machine with V wheels held in by this tensioning system, you know, just buy yourself a pack of nylon lock nuts. It's held in place by a nylon thread there, where it's clamped. So they last a long time if you're not adjusting, but they're cheap enough that if you're having any sort of tension issues. Alright, heaters have been rolling. The other thing was, make sure you don't have any dropouts on the heaters as the cable is moved. If there is an intermittent failure in the cable, you don't want to find that out at the end. You will get a thermal runaway. These things are set well, but I'm going to load some filament. We'll try a test print. Ooh. Well, there's your problem. That's a shot. This is an old E3D British pipe thread. So it's supposed to have an O-ring up there for water sealing. But this is a straight thread versus tapered thread. Metal ones are a lot smaller. This will work well enough. Good, clean extrude. Ready for test print. Well, the slicer leaves a good bit to be desired. I also feel like the machine is running incredibly slow for the drivers and the motors that are on it, the stepper drivers. I'm guessing it's due down to the firmware, so we might have to do some major modifications to get it running smoother and faster, but if any machine was ripe for a clipper takeover, it's this guy. I was impressed by the reliability. I did not do any special tuning, and it's certainly not as trammed as it could be. I really just wanted a test print quick to see how it's going on. But hey, when something's running, and something looks good, you might as well let it go. Alright, so print quality. I was intending to just print a single Fox, but I had prepared a few more parts, and the machine just kept going, which is kind of punk rock. I assume there's settings on there. It is a used machine, so I didn't go through all the settings before running it, because I'm like, let's just see what we got. This guy, you do have decent movement. I did shrink the height on these to try and, get fast prints. Was a little problem with the second Fox. In general, just bed adhesion could be better. I'm not sure if that's because of the ancient bed, or really I'm not sure how much of that is due to the well-used bed. You do still get, I'm seeing darkness from the bed on here. And I am doing my test prints in white PLA in order to accentuate any errors there might be on the machine. It's much easier to see errors in a white thing. Top surface finish is actually quite good, despite the 45-degree angle. You have just the weird little upper edge, so this was the start of the print. Printed at the angles. I know, even with the white, it's hard to see all the angle, but it was printed like so. And so this is the roughest surface. The overhanging ring came out perfectly. One of the advertisements of the 45-degree angle is that this would normally be unsupported on a regular 3D printer, but on this guy, it's basically supported the entire way. I don't know if you can see the lines on this guy. You can actually see these, and you can even feel these little ridges. This, to me, really looks like there's a loose carriage, a loose mechanical, which I definitely don't feel when looking at the system, but I'm going to take a much closer look afterwards. In terms of flatness, we had a little issue with the front sticking. Let me grab something that's... Not that my homemade workbench isn't flat, but, this was machined. Bring you guys down to see that. So, a slight bow along the back, and so major lift at the front. But in terms of flatness over the whole part, it's remarkably good. This is actually an extension for this machine itself. I think it goes like that. To set up rollers. It'll go like... That's how it goes. But in terms of print quality, the bed adhesion is the only thing that's not obviously ideal. Well, this is another benefit of the belt printer. If there's a small failure, every one of these layers is the first layer. It has a chance to recover as it goes. And for some reason, did a really great job at the end of the print, whereas it didn't. Well, I did a pretty good job at the start, but right here where we had a wide start, that's ugly. But in a place that it doesn't actually matter, this is quite a usable part. In all, I'm fairly pleased with the print quality as is. I do think that the biggest issue is the extruder in the first layer. I want to point out, why is the extruder at a 45-degree angle to the bed? Not why does the extruder move at a 45-degree angle, but it seems like if we split the difference of the extruder, angle this extruder at 22.5, then we should be able to get better bed adhesion and better print quality with only minimal corner of the nozzle dragging, which maybe even solve that with a file. I don't know. We'll do some experiments, we'll do some upgrades, but Creality CR-30, not bad. Thanks for watching, and happy printing.